Decide whether or not the given points are solutions to the system of equations. In order for a point to be a solution to a system of equations, it must make both equations too. So let's check the point 11, -6 by plugging it into both equations. So in the first equation, if I let x equal 11 and y equal -6, I want to know if this is a true statement. So let's evaluate. So 6 times 11 is 66, plus 7 times -6 is -42, and we want to know if this is equal to 24. Well, 66 plus -42 is equal to 24, so it checks. So this point is a solution to the first equation, but in order to be a solution to the system, it must be a solution to the second equation as well. So we'll check it in the second equation. So we want to know, is -2 times 11 plus y, which is -6, equal to 2? Okay, so this is our question. So -2 times 11 is -22, minus 6, and we want to know if that equals 2. Well, it's obvious that this is not true. -28 does not equal 2. All right, so since the point is a solution to the first equation but not the second, it's not a solution to the system. Let's check the other point the same way. So in this case, we're going to let x equal 1/2 and y equal 3 in both equations. So in the first equation, 6 times 1/2 plus 7 times 3, and we want to know if this is equal to 24. 6 times 1/2 is 3. 7 times 3 is 21. And 3 plus 21 is 24. So this checks for the first equation. Again, remember that we have to also check the second equation. So let's plug it in. -2, 1/2 in place of x, and 3 in place of y, and see if we get a true statement for this equation. So -2 times 1/2 is -1. -1 plus 3, does this equal 2? Well, -1 plus 3 is 2. 2 equals 2. This checks as well. So since the point makes both equations true, then we say that this point, 1/2, 3, is a solution to the system. However, the other point, 11, -6, was not a solution.